Hello, and welcome to another lesson on automated UI testing. In this video, we're going to refactor some of our automated tests to eliminate duplicated code across test cases. We're also going to write some custom code to allow test cases to share the same browser session. TestSuite is a class in Python's unit test module that allows you to combine tests that should be executed together. It provides a way to organize tests, run them in batches, and manage the execution of test cases efficiently. It's a powerful feature in Python's unit test framework that helps in organizing and managing test cases in large codebases. It is particularly useful in large projects where managing numerous test cases can become cumbersome. The test plan add task script defines a class responsible for running a sequence of automated test cases. A method in this class will initialize the test plan and add the test cases to be executed and then run the tests. TestSuite allows us to run multiple test cases one after another, but each test case is still atomic in that each script uses a different instance of WebDriver. This leads to a lot of reused code. For example, each test case repeats the login procedure: attempt first, register, then log in using new credentials. We want to eliminate this copied code and simulate the way a real user would interact with the application. First, we need a way for each test case to share the same WebDriver instance while still maintaining the independence of each test case. To solve this problem, we're going to write a Python script that contains two classes, a singleton and a WebDriver instance class that uses the singleton metaclass to ensure that only one instance of the WebDriver is used throughout test execution, preventing conflicts and reducing resource waste. The automated test script defines a class that extends unittest.TestSuite, which is designed to manage and run a collection of test cases. This class is central to running the test plan defined in testplan addTask.py. This class will contain methods that add the names of test cases to a list, execute those test cases, and ensure that the WebDriver is properly initialized while handling browser cleanup. This is what our new file structure is going to look like. We're going to create some new directories in our test project, namely test plans and web utilities. Let's get started. We'll begin with writing the test plan. Create a new directory called test cases and move all 4 of our test cases there. Then make another new directory called test plans and add a file named testplan addTask. Make another new directory called web utilities. Inside the web utilities directory, make a new file named WebDriver instance. Inside the Web Utilities directory, make another new file named WebDriver Event Listener. The WebDriver Event Listener class is designed to log messages before and after the WebDriver navigates to a new URL. The Abstract Event Listener class allows us to listen for and react to various events that occur during WebDriver's execution, such as navigation, clicks, and more. By inheriting from Abstract Event Listener, the WebDriver Event Listener class can override methods to handle specific WebDriver events. The beforeNavigate2 method takes two arguments, the URL to navigate to and the WebDriver instance, and it doesn't return anything. Logging.info logs an informational message using the logging module. This method belongs to the superclass Abstract Event Listener, and calling it ensures that any additional behavior defined in the superclass is also executed. The AfterNavigate2 method also belongs to the same superclass and performs the same logging function as before Navigate2. Save and move back to WebDriver instance. The first class we define will be the singleton class, which is a meta class. A meta class defines how classes behave. In our case, the singleton meta class ensures that only one instance of the WebDriver instance class exists. This is useful for managing the WebDriver lifecycle consistently throughout our tests. Underscore instances is initialized as an empty dictionary which will hold instances of classes that use the singleton meta class. The call method is invoked when an instance of a class is created. The if statement checks whether an instance of the class, named CLS, is already in the underscore instances dictionary. If no instance exists, a new instance of the class is created and stored in the underscore instance dictionary using the super method. A single instance of the class is returned from the dictionary, ensuring only one instance of the class exists. Next, define the WebDriver instance class, which utilizes the singleton meta class. The initializer calls the createGeckoDriver method to create a new Firefox WebDriver instance and assigns it to the driver attribute of the class. Define the createGeckoDriver method next. This method is responsible for creating a new Firefox WebDriver instance. Options is an instance of Firefox options which specify options for the WebDriver. GeckoDriver path is the file path to the GeckoDriver executable. Service is an instance of Firefox service and uses the file path to the GeckoDriver executable. Create a new instance of the Firefox WebDriver using the service and options identified above and name it Driver for simplicity. Use driver.get to navigate to localhost and port 3000. Wrap the WebDriver instance with event firing WebDriver and attach WebDriver event listener using the listener alias created in the import statement. This allows the event listener to monitor and react to WebDriver events. Finally, return the wrapped WebDriver instance. Define a new method named getDriver. This method will return the existing WebDriver instance, or it will create a new one if it doesn't exist. The last method in this class will be named quitDriver. This method quits the WebDriver instance and sets the driver attribute to none. Next, we're going to work on automated test.py, which goes into the test cases directory. The automated test class extends unittest.TestSuite. It will manage and execute a suite of test cases. The initializer takes optional parameters: a list of test cases, the name of the test suite, and the time it takes to run the tests in milliseconds. If no test cases are provided, an empty list is used. Then the super initializer calls the constructor of the parent class and passes in a list of test cases. Self.testCases initializes an empty list to hold the test cases. Self.testRunner creates an instance of text test runner with descriptions enabled and verbosity set to 0. This runner will execute the tests. Self.name sets the name of the test suite. Self.runTimeMill sets the runtime in milliseconds. Self.driver gets the WebDriver instance from WebDriver instance. Self.eventListener creates an instance of WebDriver Event Listener. If the WebDriver instance is not none, we delete all cookies in the WebDriver instance and refresh the WebDriver instance. Else, raise a value error if the WebDriver instance is none. We then define a method named addTestCase, which appends a test case to the list of test cases. The next method in this class is named execute, which will run our test cases. Current mill time defines a lambda function to get the current time in milliseconds. Start mill time gets the start time in milliseconds. RunTest initializes a variable to true to control the loop, and we use a while loop that runs until RunTest is false. Inside the while loop, we add the test cases to the test suite, run the test suite using the test runner, clear the test cases list in the test suite to prepare for the next iteration, and set run test to false if the elapsed time exceeds the specified runtime in milliseconds. Finally, we close the browser and quit the WebDriver. This class serves as the core of our automated testing framework. It coordinates the execution of multiple test cases while managing the WebDriver instance. Let's move on to coding test plan add task.py. This class will be responsible for organizing and running a sequence of test cases. Define a method named runTests inside the test plan add task class. This method will be responsible for setting up and executing the test cases, and it does not return a value. Create an instance of automated test class using the name test plan add task. This instance will manage and execute the test cases. Add instances of our test cases. Log in, add task, and log out. Call the execute method using the test plan instance to run the test cases. Check whether the script is being run as the main module. Then use the test plan add task class to call the run tests method. Now we need to refactor code in our test cases. Let's start with test case login. Change the setup method into a class method named setupClass that takes a parameter called CLS. Initialize the WebDriver instance using the WebDriver instance class and assign it to the class attribute named Driver. Don't forget to import WebDriver instance. Define a new method named runTest. This will run the login test when called. Change the name of the test method to TestLogin. Remove the driver.getCall, and instead of checking for the presence of the logout button at the end of the test case, we're going to change that to look for the add button instead. Change the teardown method to a class method named teardownClass. Remove the driver quit statement and just insert a pass. Save these changes and let's move on to test case add task. We're going to make the same sort of changes we made to test case login. We no longer need add task to support registration or login, so that code can go. The bulk of our test can be simplified to half a dozen lines of code. Save and move on to test case logout. Make the same sort of changes we made to test case login and test case add task. Delete code we no longer need. Don't bother navigating to the Manage Users page. We can test that functionality in another test. Again, our logout test can be reduced down to a handful of lines. We're ready to test our refactored code. In a terminal, navigate to the test plans directory. Invoke Python and pass in the name of the test plan. It looks like there's a problem. We're not finding the test cases directory. This is a simple fix. Go back to test plan add task and add the following import statements: OS and sys. Use sys.path.append to add the parent directory of the current file to the system path. This will allow the script to import modules from the parent directory. Save and rerun. We have successfully tested 3 functions by combining 3 test cases into a single test suite. Let's do a quick review of what we did in this lesson. We added code that made it possible for our test cases to share the same browser instance without interfering with each other. By grouping test cases together and running them sequentially, we transformed 3 independent test cases into one powerful integration test using the TestSuite class. Remember that in the context of automated UI testing, integration tests often involve interacting with the UI to validate the interactions between various UI components and the back-end services. These tests ensure that the combined parts of the application work together as expected. We now have at our disposal an automated test architecture capable of interacting with our application in the same way a human user would. If we wish, we can still run test case bad login as its own test script to test for edge cases in the login process. That concludes lesson 3.4. In the next lesson, we're going to add functionality that would allow testers to select different browsers for cross-platform testing, and we're also going to add code so our test scripts can read from configuration files. If you found this material helpful or informative, please consider hitting the like button or leave a comment down below. See you in the next video.